I'm going to read it from the textbook. It says, an automobile traveling at 15 kilometers an hour along a straight level road accelerates to 65 kilometers an hour in 6 seconds. What is the magnitude of the auto's average acceleration? So let's talk about that for a second. Now the average acceleration, a couple of things. Let's write down some data, okay? What was the initial velocity?
15.
What was it? 15 kilometers per hour, right? 15 kilometers per 1 hour. And just to kind of get you guys, this is how we should start to form the habit of doing our math homework. A couple of things I want to point out to you. If you go to page 57, right? Page 57 in your textbook, there's a whole bunch of formulas listed. And they're asking us for our average acceleration. So according to our textbook, the average acceleration is due to a change in velocity. So we say that the average acceleration, and this is on page 57, is equal to the final velocity minus the initial velocity all over the final time minus the initial time. Okay? And so this would be my initial velocity, V naught, and then our final velocity was 65 kilometers per hour. And this happened in 6 seconds. So what is my initial time if we're measuring time? 0. So I've got 0 seconds for my initial time, and we're going all the way to 6 seconds for my final time. So to find the average acceleration, what I'm going to need to do is I'm going to need to plug this information in. Here's the problem though. What is the standard unit of measure in physics? Is it kilometers per hour or something else?
Meters per second.
Meters per second. So before I can address that, I need to convert these. Now there's 2 ways to do it. We can convert these to meters per second in the beginning, or we can do it at the end. What do you guys want to do, beginning or end? If we do it at the end, we save ourselves like 1 extra step. So if I take the final velocity, which is 65 kilometers per hour, minus 15 kilometers per hour. Now notice Mr. Adams is writing down his units. You need to do that too. And then I say 6 minus 0 seconds. What I end up with is 50 kilometers per hour. Now really that hour gets tossed down to the bottom of the fraction, and I get 60 seconds times hours for my unit. Okay? But I want this answer of 50 kilometers per 6 second hours. What is the, I said velocity was meters per second, but what are the dimensions for acceleration? Does anybody remember? It's meters per second squared. So what do I need to do? Well, there's 2 things. One, I need to convert kilometers to meters. So I'm going to put 1 kilometer here. What's that equal to? 1,000 meters, right? And then I have this hours thing here. So I need 1 hour converted to what? Seconds. So how many seconds are in an hour? 3,600. You can find that conversion ratio in your book. Over time you'll memorize it. Okay? So now what I've done is I've got the kilometers will cancel. This hour cancels with this hour, and I'm left with an answer on the bottom, which is meters on the top per second squared on the bottom, because I have seconds times seconds. So now I've got to plug this into a calculator and see what I get. So let's do that, shall we? So I'm going to say 50 times 1,000 times 1, right? So that's 50,000. And then I'm going to divide that by, and then in parentheses, I'm going to say 6 times 1 times 3,600, right? Because I'm multiplying all the numbers on the top across all the numbers on the bottom. And so my final answer is 2.3 meters per second. Now, how do I know where to round this? Anybody want to guess? How many significant figures are here? 2. That's a good guess, right? You're technically supposed to go with the lowest sig fig, which is this. Did they write 6.0 in the textbook? Let's check and see. Oh, they said 6.00. So in the textbook, they actually wrote, they didn't write it this way, they said 6.00. Well, how many significant figures is that? 3. So we have 3 and 2, and remember the rule, you're supposed to do all your multiplication and division and choose the least number of significant figures. So what that means is if I round this, I got to round it to 2 sig figs. So I'm going to say 2.3 meters per second squared. What's the answer in the back of the book?
2.32.
2.32. Why did they round it to 3? What are we going to do? Well, you know what they may have done, though, is they may have converted the meters and all that stuff. So, anyways, 2.3 is good enough for me. Is it good enough for you guys?
Yep.
All right.